In this screencast, we're going to look at the principle of the AC motor, and in particular we're going to look at the rotating magnetic field. So if I have a stator of a motor, and if I put some windings around it, and I apply a phase, okay, so let's say it has a phase like that, during the positive half cycles, and that's this area here, well, the current is going to flow in around through the windings, around through these windings. So in the positive half cycle, using the right hand rule, we'll get a north pole there and a south pole there. So the flux lines will be in that direction. Therefore, on the negative half cycle, the current will be flowing in the opposite direction. So the north pole will now be down here, and the south pole will be there, and the flux lines will be in that direction. Okay, now let's say we put in windings on these poles, and I apply a phase such as that. Again, on the positive half cycle, so this area here, using the right hand rule, current will flow in through here. I'll get a north pole here and a south pole there. So the flux lines will be in this direction. And on the negative half cycle, the current will flow in the opposite direction. So the north pole will be here and the south pole will be there. And the flux lines will be in that direction. So what happens when I combine the two phases? Okay, so let's say we have phase 1 and phase 2. They're 90 degrees apart, and the poles are 90 degrees apart. There's phase 1 in purple and phase 2 here in red. And let's look at specific times. So I'm going to look at point 1, 2, 3, 4, 5, 6, 7 and 8, and the cycle repeats itself here again, so we're back to 1. At time 1, we can see that the voltage in phase 2 here is 0, therefore the current is 0. So there is no current flowing through these windings, therefore there is no magnetic field across these poles. In phase 1, the voltage is at a maximum, and therefore the current is also at a maximum, so the magnetic field will be in this direction. Okay, now in term 2, phase 1 is still in the positive half cycle, and phase 2 is also now in a positive half cycle. So there's current flowing through these windings. It's going to give me a magnetic field in that direction. And there's current flowing in these windings. And that's going to give me a magnetic field in that direction. But flux lines can't cross, so we will have to find an intermediary position. So this side is both north, this side is both south, so an intermediary position will be somewhere around here. There. So that's where the magnetic field is in point 2. In point 3, now there is no current. This is at 0, so there's no current going through these windings here. The current through phase 2 is at its maximum, so we will have a magnetic field in that direction. In time 4, this is still positive, but this has now gone negative. Therefore the current is flowing in on this winding. So the north pole is now here for this this phase, and on the phase 2 the north is still there. Okay, so the flux lines run in this direction. Again, the flux lines can't cross, so we'll take up an intermediate position which is somewhere there. So our north pole has moved from there to here, and now in that direction. At time 5, at this point, the current through phase 2 is 0, and the current through phase 1 is at a maximum in the opposite direction. So we'll have a north pole here and a south pole there. That's our flux lines. At time 6, the phase 2 voltage is now negative, so the magnetic field is going to be reversed, and phase 1 is still negative, so what we will have is the flux lines north-south here due to phase 1, and on phase 2 they will now be going in this direction here, north-south. So flux lines can't cross, so we take up an intermediate position. At time 7, the current through phase 1 will be 0, so no flux lines in this direction. Through phase 2 it will be at a maximum, but in the opposite direction, so our flux lines are going to run in this direction. And then finally in point 8, this has gone positive again, so the North Pole is now moved up here. This is still negative, so the North Pole is here. Flux lines can't cross, so we take up an intermediary position, which is there. And that brings us back to point 1, where there's 0 current in phase 2 and it's a maximum in phase 1. So if we look at how this North Pole has moved, phase 1 position 1 is there, position 2 there, position 3, position 4, position 5, 6, 7, 8 and back to 1. So we see it's rotating around the stators, and that's how you generate a rotating magnetic field. So that's what we have. Now, this is the principle of AC motors. We have a rotating magnetic field. If I stick a magnet in there, well, what's the magnet wanting to do? Well, the magnet will want to follow the rotating magnetic field. And that is the basic principle of an AC motor. Now, how do we get this magnet? Well, we can use an electromagnet. So we put a DC supply across some windings, and the electromagnet will then follow it, and we call that a synchronous motor. Or if we use the rotating magnetic field to induce a current and therefore a magnetic field in the rotor, we would call that an induction motor. And that is the basic principle of the AC motor. I'd appreciate any of your comments. Thank you.